Hi, I'm Kip Sigmund. I am a consultant with TypeSafe, and I'd like to talk about writing unit and integration tests for Scala applications. I'll start with a quick review of some of the basic concepts of software testing that you'll hear me refer to later in the video. A unit test is code that tests the behavior of an individual unit of application code, such as a method or class. These are really useful when initially writing that code, but also provide a safety harness in the future when you make modifications. An integration or a functional test is like a unit test, but it tests multiple units operating together. These tests can more closely simulate an entire feature or specification or a user story, for example. An assert is a statement used in a unit test that asserts that a particular condition must be true. If the condition is false, it causes the test to fail. A matcher is a rule that can be used as a building block with other matchers to create custom assertions in a more declarative programming style. And often when we're testing an individual unit, that unit will have dependencies on other objects. What we'll do is we'll mock those other objects, which is simulating them in a very controlled manner so that we can keep the focus of the test on the unit. Test-driven development is the practice of first writing a test and then writing the code that the test goes against. Usually in practice this is more of an iterative process because sometimes you find out that your test wasn't quite match all the specifications and you go back and forth, but it's still a pretty good practice and forces you to have high test code coverage. Behavior-driven development is a software development process that's kind of built on TDD and other established agile processes, and I could probably write a book on this, but we're focused just on the kind of testing portion, which, basically what it tries to do is have you write tests in a much more descriptive manner that kind of follow business specifications, keep the focus on your business goals for your software. In Scala, there are many testing frameworks available with a lot of features, and this is pretty cool, so you can kind of find the one that you feel the most comfortable with and use it. And I'll be showing you all the main ones. Typically, you'll put your tests in your project source, but separate them from the application code so that we can be kind of used as a different part of the build process or not packaged in your deployables. The convention in Scala projects is what we call the Maven standard directory layout, where you put your application code under source main and your test code is under source test. SBT, which is a build tool for Scala, has targets for running all these tests, and the main IDEs, Eclipse or IntelliJ IDEA, have plugins to run tests. Let's take a look at the main testing frameworks. If you've come from a Java background, you're almost certainly familiar with either JUnit or TestNG. These are Java testing frameworks, but you can also use them with Scala. They use asserts to verify test values, but they can also be used with add-ons. There's a library called Hamcrest, which is a set of matchers to allow you to kind of write more expressive tests, or Mockito is a library for mocks, or there's a whole host of libraries out there that you could use. And these tests are supported by SBT, although you have to do some minor configuration, and IDEs usually run these out of the box. Let me show you what these tests look like. This is a JUnit test for Scala right here. And you'll see this is pretty straightforward. Each method is a test, and the method name is the test name, and they know to get run by using this test annotation. And this is what I called an assert. This basically is saying that this list is empty should be true, and if it's not, the test will fail. And this is kind of a special label that'll show up if the test fails. Now in this test size method, I've shown you the basic assert. In this case, assert equals takes the first argument as expected value and the second argument is the actual value. And I can't tell you how many times I've gotten those mixed up. And here's an example using hamcrest matchers, right? So this reads a lot more like a specification. Assert that list size is equal to 3. And in this case, is and equal to are both considered matchers. And I mentioned you can combine them to kind of get expressive statements. And this reads a lot, I think, a lot better. And you really know what it's supposed to be equal to as opposed to this statement. You can also test things like, did this method throw an expected exception? And I mentioned the Mockito mock library. Here I'm just creating a very simple mock of a list that's supposed to return 1 when you call head, and then I'm just asserting that that happens and verifying that the mock, that method was called in the mock library. And in Eclipse, I'm using Eclipse. I'm actually using the Scala IDE port of Eclipse, but Eclipse will run these JUnit tests out of the box. So just right click, run as JUnit tests, and then you'll get some nice output here. Typically in a kind of a test interface like this, a green bar means all tests pass, and you'll see there's green check marks on each one of my tests. And that's kind of cool. You'll find you kind of just get a little immediate warm and fuzzy every time you see a green bar when you're writing software code. Here's a TestNG test, and you'll see this looks almost just like the JUnit test. It's testing the same things. Here's an assertion. But TestNG has some features that differ from JUnit, and some people like that. For example, you can group tests together. Here I've grouped these tests into a size test group, and then I can run some setup and tear down methods that apply just to that group. So that can be kind of neat. Now, ScalaTest is a testing framework that's written in Scala, and it's specifically for testing Scala. And it supports many different test specification styles by extending different traits, including like JUnit, and I mentioned before this behavior-driven development style of testing or test writing. It also offers integration with a lot of different test tools, so it provides a very rich feature set. And it's supported by SBT and IDEs pretty well. So let's take a look at a couple of these. This is a test using a ScalaTest trait called Fun Suite. And this allows you to write tests that in the sort of JUnit TestNG style. This should look really familiar like the tests I just showed you in those frameworks. One thing that's a little bit different is your test name isn't the method name. That your test name actually can be a string, so you can write a much more descriptive test name. And my Scala IDE provides a ScalaTest plugin, so I can run these tests right in my IDE too. And it has its own plugin interface, but it looks almost just like the JUnit interface. And same thing, green bar, all the tests pass. Now, here's a BDD style of test writing. I'm using ScalaTest word spec trait with the matchers trait mixed in. And this allows me to write tests in a much more descriptive style, almost exactly like a specification. So in this case, this calling is empty should return true for a list with 0 elements in list.empty should be true. So this kind of domain-specific language way of writing the test, these 2 lines is provided by WordSpec, and this should be is a matcher, and that's provided by this matchers trait. And I also mixed in this Mockito sugar. I mentioned some integrations with other libraries. So ScalaTest has an integration with Mockito. So this is pretty much the same test I showed you before. It's just creating a simple mock that returns 1 when you call head on it. But that's pretty easy to do. And the neat thing about these behavior-driven development style tests is that when you see the output, let me show you the output here, that the output reads like the tests. And you can see the hierarchy kind of follows it here. And some people really like that. There's another Scala testing library that's pretty popular called Specs2. Specs2 is focused heavily on this sort of BDD style, which I just showed you with the ScalaTest word spec and matchers. It also offers integration with other tools to provide a pretty rich feature set. It's also well supported by SBT and the IDEs. And if you've done any application development with the Play framework, you'll recognize this as a sort of packaged testing tool with Play. So let me open up a Specs2 test, and you'll see this reads pretty much just like the Scala test I just showed you, right? The matchers are a little bit different. These are considered matchers. This must be true, must be false, must be equal to. So the syntax is slightly different, but it's very much the same. I mentioned this, also has a Mockito integration, so I'm doing the same thing here, creating the mock. And instead of using a plugin, use a JUnit runner interface on this to make it run in Eclipse. But you'll see that the JUnit output also provides nice, clean output in the hierarchy of the tests are written. So that's pretty also. And the last framework I want to show you is called ScalaCheck. This is different than the other testing frameworks. It does something they called automated property-based testing, which and I'll show you what that looks like. But what's kind of neat with this ScalaCheck type of testing is that you write a test method with some inputs, and ScalaCheck will run that test hundreds of times using random generators each time to provide different inputs. And ScalaTest and Specs2 provide an integration with ScalaCheck, so you can write these tests in those framework too. Let me show you what this looks like. Okay, here I'm testing this property concat, right? And my sort of assertion is that the sum of the size of two lists is equal to the concatenated list size. And these are the inputs. So I mentioned this test will get run hundreds of times, and for each time, a random generator will generate two different lists of ints. And it's packaged with random generators for most of the basic types and collections of those basic types. I'm pretty sure you can write your own custom generators too. And this properties trait that ScalaCheck uses actually has a main method, so it can be used just as a standard Scala application. So that's how you'd run these tests in IDE. And you'll see here it has its threshold set that when 100 tests pass, it calls it a pass. You can tweak that, and also you can kind of filter on which tests you actually care about. In this case, I'm running the test a whole bunch of times, but I don't really care to run the test when the generated A is positive and less than 10,000. Let me show you, I mentioned that this integrates with ScalaTest and Specs2. Here's what it would look like in ScalaTest. Here I'm extending the func suite, which just kind of does the JUnit style test, but I've added in this checkers trait. And this checkers trait allows me to write these ScalaCheck tests. So this syntax looks very similar, and the test runs the same way, but it will run under the ScalaTest framework. And I mentioned before SBT, which is the build tool for Scala. And let me start that. It has testing targets to run all these tests. So if I just want to run all the tests, I type test, and there it gives me output for a whole bunch of different tests. And if I wanted to run just an individual test, I could run that using this test only target. So in this case, I'm just going to run list word spec. And so I just get output for that test. And that pretty much covers all the basic frameworks for testing Scala applications. If you'd like to learn more, you should check out TypeSafe Activator. There's a wide variety of templates in there, and most of those templates have tests and can give you pretty good ideas of how to write your own tests. There's also a template called Test Patterns in Scala, which focuses on some common test patterns in some of these different frameworks I showed you. The build tool, SBT, has documentation. They have a page on testing, which will show you how to configure JUnit, for example. Or you can go to any of these framework sites themselves. They usually have a quick start guide that can get you up and running with pretty simple tests using basic features in a very short period of time. Or they have user guides to teach you about the more advanced features or how to write more complex tests. And you can also find me on Twitter at Kip Sigmund, and I'll be happy to steer you in the right direction if you get lost. Thank you.